let's get started. My name's Dan Young. I work at a company called Engineer Better. It's a Cloud Foundry consultancy. And the title of this talk is When and Why Does Portability Matter? Now, before we start, can I just check who in the room operates, builds, or sells infrastructure? And who would consider themselves on like the application side of things, so a developer or application owner or, okay. So I'm hoping this talk will appeal to different types of audience. I'm hoping that if you're the kind of person who is trying to make a decision about whether to use a particular type of infrastructural technology or particular cloud, that this talk will be for you. I hope that if you want to consider using OpenStack but would like to have some options, maybe, for the future about leaving OpenStack or using other clouds in complement to that, this will be for you. And if you don't really care about where your applications run, but you like using lots of different clouds with a common interface, this talk is for you too. My name's Dan. As I said, I work at Engineer Better, and we do Cloud Foundry stuff predominantly. And the way I describe this to my friends and family is that we are delivering software for people who deliver software. And that's kind of how I like to sum it up to them, rather than trying to explain what PaaS is and what 12-factor apps are and all that stuff. So that's what we're up to. So the rough running order for today is I'm going to talk a bit about sort of where we've come from, so the state of cloud in the first sort of decade. And I'm going to focus largely on public cloud. That's my background. I've worked a lot on customers who are using public clouds. So a lot of what I say will be sort of more tailored towards that. And when I say multi-cloud, I'm really trying to update the debate on this portability issue between clouds and interop between clouds. And largely that debate has been focused on APIs at the infrastructure level. So it's API and semantic interop at the infrastructural level. And I believe that really that kind of portability in multi-cloud type world is possible, but it's going to be something which we do at the application layer, at the PaaS layer. And that's essentially what this talk is driving at. So I'm going to look a bit about the conditions that can make that possible. So market conditions, people's attitudes, and what's happening in the data that's available. And the ways in which multi-cloud can become a real thing. So actually, how does that work using parts of the Cloud Foundry ecosystem? And ultimately, what does that mean for your decision-making processes? So how does it impact you? Now, obviously, this is an OpenStack event, so I did want to set some context. If you're not familiar with Cloud Foundry, I'm not going to go into the detail of what it is and why it exists. There's lots of other great presentations that will do that if you search online. But I did pick out this quote from Josh McKenzie, who was one of the founders of OpenStack. I think he was at NASA, and he was at Piston Cloud. And he sort of put it in context like this. So if you're building a cloud today, you probably end up using OpenStack because it's the best tool for that job. If you're building a PaaS for developers, you should use Kubernetes or Run C. And if you're building applications for your business, you should put them into Cloud Foundry. So that's the sort of layers of the stack and helps you to maybe draw some context. So where have we been up until now? So we've had about 10 years of cloud since AWS appeared. And in that time, it's largely been a one-horse race. So we'll look a bit later at some of the data on things like Magic Quadrants and survey results. But largely, in the public cloud, there's only really been one key player there with Microsoft and Google sort of dragging behind. And the whole race into public cloud was driven by the need for speed. And there was this explosion of activity with developers having direct access to infrastructure. And the people who did that first had an advantage. So if you were the first businesses in the marketplace to start to adopt AWS, then you had an early mover advantage because you had the skills. You began to learn those best practices, those new best practices of how to work. But over time, that advantage starts to erode because it becomes ubiquitous, and those skills become ubiquitous. So there's no real competitive advantage in using AWS. So that's where we've been, in a general sense. And the important thing to realize is that the world doesn't stay still. No matter how sort of cut and dried you think things look. Change is a constant, and that's what I wanted to explore a little bit. So what conditions do we have at the moment for maybe threatening the status quo? Well, the first thing is that global systems are very fragile, and by this I mean the political systems that our suppliers operate in and the economic systems that they operate in. We've had things like Brexit, we've got the Trump phenomenon, we've got a very, very unpredictable political system. We don't know what the outcomes of that will be in terms of data legislation and political drift. And there isn't really any single institution on earth that is immune from that stuff. And it doesn't matter how big you are. So if you've only got one name, you are a single point of failure. This is undeniable fact. Regardless of the sort of empirical data on things like lock-in and the economic debate of whether you should trade speed for portability, stovepipes feel wrong. There's just something visceral about the reaction that IT departments and developers have to being made to use something, and they can't get out of it. And I picked this amazing quote from Brian LaRue, who said that the AWS console is this generation's Visual Studio. And I thought that was quite funny, so I stuck it in here. The other thing the sort of key trend that I think we should take notice of is that you've got these new best practices. So we've had sort of 2 decades of enterprise-driven development in IT, where we've had unreliable software on reliable hardware. And that's flipped now, so developers are being encouraged to write reliable software on unreliable hardware. And the 12-factor app is a thing, and people are being encouraged to write stateless applications that are not tied to any particular shared state. And they have backing services, and they don't store configuration in the application. And microservices, follow this pattern. So architectural patterns are changing. Now, Barbara Liskov, who's institute professor at MIT, and she was the first woman to get a PhD in computer science in America. And she won the Turing Award for work that led to the development of modern object-oriented programming. And she said this: modularity through abstraction is the way things get done. And we live in a world where there isn't going to be necessarily any limit to how far we can abstract. There's no reason that we're going to stop abstracting away from what lies underneath of virtualization, containerization, applications as the unit of currency. And there's no reason why we should simply stop at having these siloed clouds and not being able to abstract away and have a common level of interaction between these. And when you look at history, you see not only abstraction as being a pattern that occurs in computing over and over again, but infrastructure itself, so infrastructural technologies, like being shared. And infrastructure throughout history is always, as a general rule, evolved to a state where it's being shared by people, because that's when we get the maximum value from it. And this also means that, in a general sense, with things like telephones and electricity and railways and roads, we have portability between different providers of those things, because we get maximum value from that. And there's also a general trend on the internet for technologies to bubble up, which allow us to have independence from providers. For example, with like email. When you first got your dial-up account at home, you'd have an email address that was linked to your provider. Now you have Gmail, or you used to have Hotmail, or whatever else. You used to have SMS on your phone. Now you have WhatsApp. So there's a general tendency for things to become like an over-the-top provision of a service. And ultimately, competition never stops. So if your competitor in business is armed with something that enables them to port between clouds, you will ultimately find yourself needing to do exactly the same thing. And that is what will drive, I think, the move towards multi-cloud. When the conditions are right and the tools exist to do it, I suspect that we're going to see it starting to happen. So the thing we're trying to mitigate by with this concept of being able to move between clouds is lock-in. So what is lock-in exactly? Well, there's a book in 1998 called Information Rules that sort of dug into this a bit and looked at the information economy and the digital economy and tried to understand how you could apply common economic rules and principles to this. And they defined lock-in as the fact that if you make the essence of lock-in is that your choices in the future will be limited by your investments today. And there's a cycle that goes with it. There's this lock-in cycle. And it's fascinating, actually, because in the first sort of phase of cloud, depending on how much you've adopted AWS, you may find yourself going around this loop several times. And what happens is that you aren't born locked into any technology, but you make a selection of a brand, and then you begin to try it out. And as you move that into common practice and production, you become entrenched. And then you get to the stage where you have to make another decision, and you think, shall I go with a different provider, or shall I just stick with the one I've got, because otherwise I'm going to have to tear all these things out. And you go around the loop again, and every time you go around the loop, the world starts to look more and more different because you've got fewer and fewer options available to you. But if you understand this and you're able to play the game, then you can sort of mitigate the costs of lock-in as you go around the loop. And suppliers are very good at understanding lock-in, but on the buyer side, in the digital age, and particularly in cloud, we've been really bad at it. We just have not paid attention to the costs, the switching costs that we've been incurring using public clouds. And I thought I'd go and try and find evidence of this sort of unmet demand for portability. And it was astonishing to me that AWS had been so adept at playing this lock-in game that they were even getting to the stage where, Andy Jassy was standing up and saying, customers kind of want to be able to use different clouds, but they just give up and end up using us. So, there was an interview, or it was him standing up at one of the events and sort of explaining, trying to talk his way out of the fact that AWS was locking customers in. And there's plenty of survey data out there that I found that showed that customers that have been around that lock-in cycle a few times are finding their switching costs astronomical. So they don't leave, but they wish they could. And they wanted to find out what other what other clouds have to offer as a complement. And this data from RightScale showed that customers wanted to have the option of using multiple clouds. So 82% wanted to have a multi-cloud strategy where they were able to use either private, public, or a mixture of the two types of cloud in hybrid. And 78% of companies that were interviewed by Wakefield Research for LogicWorks just in July of this year said that they believe that the concerns about vendor lock-in were preventing their business from getting the most out of cloud. So that's what the customers think. What do the analysts think? So I took 3 magic quadrants, the successive years, and drew little boxes around the sort of general division between these two worlds. And what you can see here is it's incredibly polarized now. And the bottom box there on the left with the black sort of contenders to the 3 leaders, which are Amazon, Microsoft, and Google, that black box is really a shrinking island. It's quite apparent. And there's obviously a big divide. And the only companies that aren't going backwards are Google, Amazon, and Microsoft. And Microsoft's actually gaining on AWS. So it shows that there is some movement there. But the diagram itself in the Magic Quadrant this year wasn't the most remarkable thing about it that I thought. When I actually read through the report, I found this statement, and it said, organizations can now consider Azure to be good enough. And good enough is a very important phrase because it's almost the definition of a commodity market. When something is good enough to use as an alternative, and you can stop thinking purely about the difference in the technical features, that's when you start to get towards a commodity and potentially even a utility market. So that's all of the sort of conditions in the marketplace. We've had these 10 years of cloud. There's certain things that are happening, and people's sort of tensions and desires for multi-cloud are starting to bubble up. What kind of future could be possible given these conditions? Well, multi-provider portability is something that is possible today, and we'll talk a bit about that in a minute. And when we're in possession of that, we are able to manage our switching costs. So we're able to be aware of going around this loop, and we're able to maybe even negotiate, say, with our vendor, because we're in possession of a tool that enables us to leave a particular vendor's technology, thereby changing the economics of the situation. And we could even be in a situation where, if enough people do this, we end up with a competitive utility market for our public cloud providers. Open source is really, really important to making these sorts of things happen. Simon Wardley, who has done a huge amount of work on commoditization and explaining the cycle that IT activities go through, said this about open source: it's the only practical way of creating and competing in the modern computer utility world. And of course, that is the basis for Cloud Foundry. And as I said, this isn't a technical talk about Cloud Foundry. I am going to go into in a minute about how Bosch works and why it's really the underpinning of the inspiration for this talk. But Cloud Foundry, combined with the foundation that governs it and Bosch underneath, is a very, very powerful combination of things. So Cloud Foundry is the application level PaaS, which enables developers to have a self-service experience. They don't have to think about infrastructure or the plumbing of the infrastructure. They simply are able to push their application into the cloud. The Cloud Foundry Foundation that owns the source code assets that makes that possible is, in the US legal terminology, called a 501c6, or 501c, I think, sorry. It means it's a non-profit organization, it's a trade organization, and that source code for Cloud Foundry, unlike many other open source projects, can never legally be transferred to a single commercial body anywhere. So it makes it very, very difficult for any one company to do something evil with Cloud Foundry, which is really important. And when you combine all of that with something called Bosch, which is very, very little known but incredibly powerful tool for managing the life cycle of distributed services, and you understand how Bosch works, you start to imagine a world where multi-cloud is possible. And Bosch is the technology that can do that. And Bosch, I've described this before as being it's like a travel adapter for cloud. So I take it for granted that I can pick up my laptop, and as long as I'm in possession of the right travel adapter, I can go to any country in the world and I can plug it in and it's just going to work. And I don't really have to think about that. And I don't have any major switching costs from doing that. All I've got to do is buy a travel adapter and swap the travel adapters according to where I'm going. And the part of Bosch that enables this to happen is called the CPI. It's a cloud provider interface. And there's a number of different CPIs for different types of cloud, including OpenStack. And once you're in possession of this technology, you start to see the world a little bit differently. And you can decouple your data, your services, and your applications from the underlying cloud. And it makes it very, very useful for businesses to be able to do that. So I've picked out some of the CPIs here. This isn't all of them. It's the ones that I know of being used in production today. Obviously, the ones that are most commonly used are AWS, Azure, OpenStack. IBM operate their Bluemix platform on SoftLayer, so they use their own. They look after the CPI for SoftLayer. And the Google Cloud Platform CPI has come from nowhere to suddenly be very, very mature quite recently. So that's actually come right up the rankings. And the way that Bosch works is effectively that you have, it changes the paradigm away from traditional config management to enabling you to think about things in a completely different way. So what you would have is a manifest, which is a YAML file that describes what your world looks like, I should say, sorry. And it describes the number of boxes you have of different, or number of instances you have of different types, like this many web servers, this many database servers, this many application servers, and in looking in these networks. And then you combine that with a release. So whatever software you're actually looking to deploy comes in a packaged release, which is a tested and proven to work combination of software, which you can feed parameters into through the manifest to change how it works. And when you combine the manifest and the release with the CPI, you've got this layering of components that enables you to change things. So if I want to change what my world view looks like of my deployment, I change the manifest. If I want to change the dimensions of my deployment, if I want to scale from 5 to 100 web servers or application servers or whatever my component is of my system, I change the manifest. If I want to change anything about the software itself, say there's a security vulnerability that I need to update very rapidly, I change the release. And if I want to change clouds entirely, I can change my CPI. And that enables me to take everything that I had and drop it onto a different cloud, which is incredible, really. So with all of that taken into account, I think these are the questions you need to ask. How can I better manage my switching costs now in 2016, given that AWS, if I'm in public cloud, is not the only game in town? And if I'm building a private cloud, so I think that private cloud seems to be, from today's presentations, one of the sort of driving things with OpenStack. How could I manage my switching costs there as well? And what is the additional marginal cost of me investing in these types of technologies? And then how does that compare with the marginal benefits of being able to switch easily between clouds? Who's doing this already? So here's some examples of early Cloud Foundry adopters. So the kinds of customers for whom this is really important are the ones where the stakes are really, really high. And governments have started to adopt Cloud Foundry. So the British government, US government, Australian government, and banks is another really big hotspot for Cloud Foundry. So you've got the biggest bank in the world, JP Morgan using it, Citi, BNY Mellon. I know some others. I'm working with another bank at the moment who's adopting Cloud Foundry, precisely because they want to have the self-service capability for their customers and their internal developers, but they don't want to be locked into any particular vendor. So they can potentially pick up this platform and move it from internal to external or vice versa. So where can we go next? We're in a world where we have good enough alternatives in public cloud. We're able to manage our switching costs with tools that enable us to switch between clouds if we abstract appropriately away from them. And when we have those options, we put ourselves in a position where we have a competitive advantage over other people in our competitive set who don't have those capabilities. So that's the talk. Does anyone have any questions? Yes?
Who are the main contributors to Codebase these days?
So the main contributor is Pivotal. The way it works in the foundation is that you generally have more influence over things if you contribute more. Pivotal are the main contributor. The other platinum members are HPE, IBM, SAP have done a huge amount of work on the CPI for Bosch for OpenStack. So that's the OpenStack CPI wasn't particularly in a good state before SAP started working on it, but a lot of their products are based on that now, so they've really brought that on a long way. It works with, it's actively tested at the moment with Kilo and Liberty. I know it definitely works with those two. I think it works with, what was the one before that? Juno, yeah. So it does work with Juno, but that's not part of their acceptance testing at the moment for the CPI. So yeah, but yeah, to answer your question, Pivotal are the main contributor to the code base. Pardon? Google aren't a foundation member, but they are, as you might expect, the contributor to the CPI for Google.
So from an OpenStack perspective, what do you need to run on top of OpenStack to be able to benefit from
So Bosch would need, the way you would deploy that is you would create in OpenStack the network, basic network and security topology you need. And then you would deploy a Bosch director, which is a single VM, onto an OpenStack VM. And then on the Bosch director, you would put what's called a stem cell. And the stem cell is an image which contains your base operating system that is going to be used for your releases to sit on top of. You upload the stem cell to the Bosch director. You upload your releases to the Bosch director. And the manifest, which tells the Bosch director what you would like to do with this stem cell and release. And then the Bosch director will call the OpenStack APIs using the CPI to actually interact and to create that environment for you.
But effectively creating an expanding Cloud Foundry infrastructure as commands carried over the control plane.
Yeah, so it can be used to deploy any type of software, but it was invented for the purposes of deploying Cloud Foundry, for the simple reason that when Cloud Foundry was first invented, you had to use Chef to deploy it, which really didn't work very well. And Bosch changed all that because it enables the entire system. It answers the question, how do you continuously deploy an entire set of virtual components for a distributed system? And it's very difficult to do that with traditional config management because they're not aware of interlinks between distributed components. They're good at deciding what goes in the box, but not what happens between boxes. So that's the essence of Bosch, is that you're trying to achieve that. And you can do things in a very, very graceful way. So it will begin to update, say, the software on one instance, and if that fails, it will stop and just not do any more. And because Cloud Foundry itself is a self-healing system, you could feasibly destroy and recreate every VM that sits underneath Cloud Foundry every few hours in your data center without affecting users because of the way that these systems all interact. So, yeah, it's quite impressive. Any other questions?
I'll go again.
Yeah.
So, I mean, one of the common pitfalls of choosing something that works over multiple different platforms is you end up with a lowest common denominator approach.
Right.
Now, I think you speak to that when you talk about good enough.
Yep.
Enough of a common set of features across all the things you're targeting.
Yes.
That you can do anything that you want to do. But I mean, is it the case that there are cool features in some of these clouds that you don't exploit because they're not?
Absolutely. Well, yeah. I mean, Bosch manages virtual machines which underpin services, so you can deploy any data service like Mongo, or you can deploy something like Hadoop, or you can deploy Cloud Foundry. But I think what you're talking about is something that's really, really useful that you wouldn't get unless you deployed your own DNS service like Route 53 or something like that, or something that's peripheral or...
Exactly.
Yeah.
There are two ways you can approach it. You can either say, look, there are differences between the potential targets, and so you get a slightly, as the user of Bosch, you'd be exposed to some of those differences and you'd have to select. Or you can say, no, it's going to be one interface. We will only support features that are present in all of the clouds that we target. And that second thing might be enough. There are real problems with the first because you're suddenly defeating the object of your multi-cloud capability. But there are disadvantages of the second as well.
Yeah, I think that it's not an either or. You don't, if you were to adopt this kind of approach, you wouldn't just need to say, okay, I'm going to deploy Bosch onto OpenStack and AWS, but I'm only ever going to use what I can deploy myself with Bosch. You may make the decision because you're managing your costs to say, okay, I am going to use DynamoDB or I am going to use Route 53 because I get this advantage. But because I've deployed all the other elements of my system using Bosch, I've reduced my switching costs. So it's really, I think it's a tool you can use to manage your costs in that way. Yes, I think so. It's not an exclusive thing.
So from a maturity perspective, if you were betting your career on the next app, would you do it this way, or would you wait for 12 months because certain things would?
If I was adamant that I wanted to run my own platform, which not everyone is, then I would I would probably, then I would definitely use Cloud Foundry. And if I was operating my own Cloud Foundry, I would get this by default because I'm using Bosch. However, I'm working with customers who have very, very different attitudes to that. So a very large retailer I'm working with in the UK doesn't even want to touch infrastructure. They have data centers, but they don't want to do it anymore. You know, they've got their enterprise systems like IBM WebSphere or whatever else sitting there. But in terms of the new cloud native apps and their 12-factor apps, they're not going to build a new infrastructure for that. They're just going to put it into one of the public Cloud Foundry providers like IBM Bluemix and a selection of others. With the banks, they have a very, very different risk profile, so they are still very wedded to the idea of running their own infrastructure. But it's nice for them because they know if they deploy Cloud Foundry on top of OpenStack or VMware or something else, then they're going to be able to pick that up. When the time is right and the market conditions have changed and data laws have changed, they can go wherever they want. And for governments, obviously it's hugely important to not be connected directly and totally tied into a commercial entity like AWS, which isn't even a British company. So, you know, the British government are doing an amazing job with GDS of building out their Cloud Foundry. So, yeah, I think it depends who you are. I would certainly use it. I mean, I have bet my career on it because I've started a company which specializes in Cloud Foundry. So, the answer is yes. But yeah, I hope that answers your question.
It does, thanks.
How close to the edge is it? You're saying it's Liberty, it's supported by it. How quickly are things moving forward?
Is it Mikata that's the one? Yeah, that's listed. So I'll probably go back up to this page. Where is it? That one. So if you go to Bosch.io, you will find a section in the documentation on the latest OpenStack information, what's supported, what's not, any sort of slight gotchas there are on different releases of OpenStack. I guess the speed at which it can keep up with the development of OpenStack is really down to how much investment SAP choose to put in at the moment, because they're the main driving force behind that part of the CPI. But yeah, it's documented as working on Mikata.
Because presumably there's a consequential lock-in with slow-moving catch-up. If you invest a lot of time into something that gradually gets further from the edge, then essentially a lock-in at different time.
Could be something to consider, yeah. Okay. I can't see any other hands. So thanks a lot for listening. I'll be here if you have any other questions, and enjoy the rest of the day.